Hello friends, today video is on liquefaction potential uh, of a ground having shear wave velocity as 150 meter per second. The soil type is silty sand and the fine content is 20%, and the magnitude of the earthquake is given to you as 6.5, and the peak ground acceleration Amax is 0.16 times g. Saturated unit weight of the ground is given here. So if you look to the solution of this problem, the gamma site is given as 18 kilonewton per cubic meter, and groundwater table is going to touch the ground level itself, and we have to find out the factor of safety against liquefaction potential at a depth below level ground at 8 meter. So Z equal to 8 meter, we need to find out the factor of safety against liquefaction, and the index F is 0.75. For the relative density of the ground is 50%. So the solution of this problem is we need to find out the factor of safety against liquefaction. So the factor of safety based on the shear wave velocity here will be the cyclic resistance ratio corresponding to the magnitude of the earthquake, which is given to us as 6.5, divided by the activating force, that is the cyclic stress ratio. So this is the factor of safety against liquefaction. So this we need to calculate it from the given information. So first of all, denominator CSR, we know it is given by the equation 0.65 into peak ground acceleration Amax divided by G into sigma naught, the total overburden pressure at Z equal to 8 meter, divided by effective overburden pressure at that point into reduction factor. So this will give you the value of CSR. So CSR can be calculated very easily. Let us calculate and find out the value of CSR. So CSR, as you can see over here, depends upon this, which is already known to us. So 0.65 Amax by G is given to you as 0.16, and the total overburden pressure will depend upon what is the saturated unit weight, that is 18 kilonewton per cubic meter, and the depth Z is 8 meter. So this we can calculate in kilopascal, and the effective overburden pressure will be the total overburden pressure minus unit weight of water into Z. So this also we can calculate it. Unit weight of water will be 9.81, and Z is given to you as 8 meter. So we can take our calculator and compute all the values over here. So this becomes 144, and this becomes 65.52, and the reduction factor RD is given by 1 minus 0.00765 into depth, at which the cyclic stress ratio is to be found out. So this we can calculate it, 1 minus 0.00765 multiplied by 8. So let's calculate this value. So 1 minus there is 0.9388. So now all the values are before us. We can substitute in equation 2. Sigma naught is 144 and sigma naught prime is 65.52 and reduction factor is 0.9388. Therefore, the value of cyclic stress ratio CSR can be computed. So let's calculate this. This gives you 0.21458, 0.2145. This is the value of CSR. Now, next is CRR. So, CRR, cyclic resistance ratio, has to be found out for MW equal to 7.5. And the formula, either you can find it out from the curve plot given in the IS code, or what else you can do it, that you can use the formula and calculate it. So this is CRR 7.5 can be calculated as A, that is factor, into VS1 shear wave velocity after correcting it for overburden divided by 100 whole square, plus B into another factor into 1 divided by VS1 star. The maximum value of the shear wave velocity minus corrected shear wave velocity minus 1 upon VS1 star. So this is the formula that you need to use it for calculating CRR 7.5, where the coefficient A, if you look to the IS code, uh, you get the value of A and you get the value of B for the given curve. You can easily find it out. The value of A is 0.022 and the value of B is given as 2.8. So this you can find out from the IS 1893. That therefore, and Vs1 is the corrected value for overburden pressure, and Vs1 is going to be the value of atmospheric pressure divided by effective overburden pressure to raise to power 0.25 into the shear wave velocity. Here the shear wave velocity is given to us as 150. So you can easily calculate this. So PA, as you know, is going to be 101.352. So PA is known to you. Sigma naught prime you have already calculated as 65.52. So this is known to you. Raised to power 0.25 multiplied by Vs is given data as 150 meter per second. Therefore, the corrected value for effective overburden pressure of Vs can be found out. Let us calculate it. So I will calculate this. One zero one. This is 167.284 meter per second. So this is the corrected value of Vs for providing for effective overburden pressure. This is the corrected value which is given to you. So now Vs1 is known to us. Now Vs1 prime can be found out from the IS code, and that is going to be equal to limiting value of Vs1. So this Vs1 prime can be found it out as the limiting value. So let us calculate this. So Vs1 prime star equal to limiting value of Vs. So for given fine content which is 20%, the limiting value of Vs is given to you as 200 meter per second. So this is also known to you. So in equation number 3, therefore, CRR for 7.5 you can substitute and get all the values. The value of A is 0.022. VS1 is already calculated, and you know the value of VS1 as 167.284, and also divided by 100 whole square, plus B is also found out as 2.8 multiplied by 1 upon VS1 prime is 200 minus VS1 has been calculated as 167.28 minus 1 upon 200, that is the limiting value of Vs, which we have found out from IS 1893 figure 10. So this we can calculate it quite easily. So let us calculate this and find out the values. So this one 0.022, one 1.6728 square plus 2.8 into 1 divided by 200 minus 167.28 minus 1 divided by 200. This is 0.133. So the value of CR, therefore, the value of CRR for earthquake magnitude of 7.5 has been calculated from this expression given in equation 3, and this is 0.1331. This is the value. So now what are the known values? We already know CSR, we know CRR. So CSR is already known to us. CRR for 7.5 we know it. Therefore, let us calculate for CRR equal to 6.5, because the magnitude is here given as 6.5. So here we need to calculate from this CRR value the let us calculate CRR corresponding to the magnitude of earthquake equal to 6.5, and that will be CRR for the magnitude of 7.5 into the scaling factor MSF into K sigma into K alpha. So CRR is 0.1331. How to find out this magnitude of scaling factor is quite simple. As you know, the magnitude can be found out quite simply by using the equation. So this is a scaling factor is going to be 10 raised to 2.24 divided by MW, that is the value of MW is 6.5 raised to power 2.56. This is the value of scaling factor, and also we can calculate the value of K sigma. As you know that we can easily calculate the value of K sigma. So K sigma can be calculated as effective overburden pressure divided by this is total overburden pressure raised to power F minus 1. If this value is to be calculated, if the depth is going to be more than 15 meter, otherwise this value becomes unity. So here the depth is Z equal to 8 meter. So this is the value. So it is not very deep, and therefore let's take this one. So a scaling factor, let us calculate, and this becomes like this: 10 raised to 2.24 divided by 6.5 raised to 2.56. One point 4139. The scaling factor. So therefore, I can substitute all the values and get the value of so MSF here is 1.41 into 1 into 1. Right? So if you calculate this, you are going to have 1.41 multiplied by 0.1331 equal to, and for level ground K alpha is always 1. This comes out to be 0.1881. So this is the value of CRR 6.5. Therefore, final answer, that is the factor of safety, will be CRR corresponding to the magnitude of the earthquake divided by CSR. So the value will be 0.1881 divided by CSR is 0.2145. So divided by 0.2145, the value comes out to be 0.877, which is less than 1. Therefore, at 8-meter depth, the factor of safety is less than 1, and therefore at 8-meter depth, ground will liquefy. So that's the answer. So friends, it is quite simple to calculate based on shear wave velocity. Only thing, you need to correct this value for effective overburden pressure, and this is the formula. So you can correct it, and you can follow the procedure, and you can get the factor of safety. So final answer is 0.877, which is less than 1, and therefore the ground will liquefy. Friends, I hope this has been very clear to all of you. With this, the liquefaction chapter is over, and in my next video, I will go to the a chapter which is very important, that is sheet pile. So sheet pile and cofferdam. So how to calculate the depth of embedment in a cantilever sheet pile or in anchored bulkhead, that I will discuss in the next video. I hope you like it, and if you have any doubt, please post your doubt, and I will try to give my best to all of you. Thank you very much.